All right, here's that second example that I said I would do. And I was thinking that these are the type where you're going to see that inverse tan rule more often than not. This one doesn't happen to have it appear, but it sure looks like it could when I see that x squared plus 9. But I just thought about that. But so don't panic if you see it. Just know that if you get a constant like a 1 or a 2 or something over an irreducible quadratic, that you can use that inverse tan rule. Okay, so here it is again. Now I notice I've got a repeating linear function. I think this is actually question 18 in your assignment, so just double check that. And then I've got an irreducible quadratic, so I'm going to set this one up. 4x cubed minus 3x squared plus 6x minus 27 over x squared plus 9 equals. So I've got my linear repeating, so I'll put those down. And then I've got that irreducible quadratic one, and we saw in the last video or last example that when we do that, we start with something like this. Okay, and then of course dx and all that. Now it's just all the busy work that we were doing before, so multiply the whole thing by our factors. So our common denominator is x squared plus 9. X squared plus 9. That leaves us with 4x cubed. And it always works out this way. The left-hand side always cancels out perfectly, which is wonderful. Equals, on this side, I'm going to have x squared plus 9 plus b x squared plus 9, and then plus the binomial of cx plus d times x squared. So I'll go and I'll simplify that on the next page, but you can see how we just eliminated the fraction, and then we'll just carry on. All right, so here it is all simplified. So now I'll break out my coefficients. So I got an x cubed in this one. I've got an x squared. I got an x term, and of course we have our constant term. So we'll deal with our coefficients. So on the first one, I get 4 equals, it looks like a plus c. For x squared, we got negative 3 equals, looks like b plus d. For our x term, it looks like we got 6 equals negative 9a. And then our constant, we got negative 27 equals 9b. So we got a couple things that we can reduce here right off the hop. I see that a is going to equal negative 2/3. So that one's good. And b will equal negative 3 by the looks of it. So that works out nice. And now we can just take those and plug those in. So if b equaled negative 3 and I add it over, I get d equals 0. And if my a equals negative 2/3 and I do a little mental math, I get c equals 10/3. So we've got our terms. Now, of course, that d equals 0 doesn't scare me. It kind of makes it nice because now I don't have to worry about that so much. When I plug everything back in, I end up with, well, let me look here. There's our a. So, oh, this was a positive 9. My bad, you guys. So that's positive 9 there in our x. I gotta better circle that one up, and positive 9 here, which is going to make this a positive 2/3. And I didn't catch that earlier, but I kind of looked here. So our integral now should be the integral. I'm going to take that whole constant out, 2/3 of 1 over x. We know what that's going to give us in the end. B is negative 3, so I'll do the same thing there. And that'll be over the x squared term. And then we can go and say, and we'll do substitution on that one, factor out the 10/3 on the irreducible part, and we'll be left with it'll be 1x when I take that c out, because d is 0, so it doesn't really matter. If it was something else, that would change the whole game. X squared plus 9, like so. So on the next page, we'll work at this. I mean, I'll go and do this one right now. This one's pretty straightforward, ln of x. And then using u equals x on this second one, and using substitution, it's going to change it to plus 3 over x. That's gonna be just with substitution. I won't do that just to save time, but you can trust me on that one. And now it's this guy here where we got to do the work, and I'll do that on the next page. So I'll just rewrite it here for you, so we'll treat it like a whole nother step, like so. Okay, so like I said, we're going to do substitution on this part here. So I'll say u equals x squared plus 9. On this one here, u equals x squared plus 9. Whoops, 9. Why isn't that working? There you go. Du equals 2x. I'll divide the 2 out, get du over 2 equals x dx. I should put the dx there as well. Okay, so that simplifies that. So now I can come back over here. 2/3 ln absolute value of x plus 3 over x, which we did these on the other page. If I take the 2 out, it's going to be 10 over 6, so that's going to reduce to 5/3, which is beautiful. And then I'm going to have 1 over u, integrate that. I get the ln of u, which is the ln of x squared plus 9, and then plus my constant. Again, just using substitution method. So in this one, we didn't have to use that inverse tan rule. If d was some other number, then we would have had to, okay, because we would have wanted to split that up and do different things with it. But we didn't have to in this one because d worked out as 0. So I hope that helped as well.